Hi, I'm Jonathan Bowes from the University of Strathclyde.
And I'm James Dixon from the University of Oxford.
We're both providing technical support and fact-checking for mock COP26, and we're here to talk about energy.
So energy is everything that we do. The future of human society and the ability of humans to avoid disastrous climate change is, in a way, the future of the energy system.
So, that's some big claims that James makes. So let's think about how humans use energy. We can broadly break down primary energy use into four categories. The first is the energy used by industry, making things like phones, cars, and everything else that we use. Secondly is the energy used by transport. This is moving around people and those things. All the energy used in cars, trains, planes, and many other forms of transport. Third, we have the energy used in buildings. This is the energy required to heat those buildings or cool them in order to make them comfortable and habitable for humans. Energy required to cook and produce our food. And finally, we have electricity. This is the energy generated by power stations used to power our mobile phones, televisions, and a myriad of other things within our society.
But not everyone on the planet has fair and equal access to energy, do they?
Around 1 billion people have no access to electricity, and more widely, the amount of energy used by different countries varies hugely. Energy use is really strongly linked to human development. The more energy a society uses, broadly speaking, the higher its GDP, the better education and healthcare outcomes. Energy is integral to human society, so much so that affordable and clean energy is one of the 17 United Nations Sustainable Development Goals. But it goes beyond that. Energy is an enabling factor for all 17 of the goals. Quality education can be enabled by access to the internet. Health and well-being by providing cold chains for vaccines in healthcare centres. And climate action by reducing the emissions of our energy system using renewable energy. Energy is the golden thread that ties together all of these goals. What is renewable energy and where does it come from?
Well, renewable energy, in short, mostly comes from the sun. So if you add up all the sunlight that reaches the Earth's land area over a year, so that's about a third of the Earth's total surface, there's about 2,000 times global energy consumption. So that's everything that Jonathan talked about, from transport to buildings to electricity, 10 times the energy required to keep everyone in permanent flight should we choose to do so. So before you ask, why aren't we pursuing this as a viable action, let's just think about what happens to this solar energy. So for one thing, the sun heats the oceans, it heats the air above the oceans, and this rises up in warm, moist clouds over and above the cold air, and this kind of convective current is the thing that causes the wind. The wind rushes across the oceans, and then that causes waves. That same warm air condenses to form clouds, which then turns to rain over our hills and then forms rivers down to the sea again. The sunlight also causes plants to grow, so plants are effectively taking carbon dioxide from the air and making it into carbon and storing it in their stems and leaves. And all fossil fuels is millions of years of these plants and animals that have decayed, died, and been buried among rocks. And what we're doing now is burning them, releasing that trapped carbon into the air at a rate that is way too fast, and then heating up the planet. So aside from this renewable energy from the sun, there's also a little bit to be had from the tides, which are caused by the moon, and from geothermal energy, which is the energy coming from the hot center of the Earth. So how much do we really need? So if we imagine all that sunlight that's coming in on the land area of the Earth as 100 cubes of energy per square meter of land, then the global energy demand, as we said, is about 1/2000th of this. So this is about a 1/20th of a cube of energy. So at first glance, it looks like this should be an easy problem to fix. Over the past 50 years, this energy we need around the globe has grown by about 2.4% every year, which sure, so in 100 years, it looks like it might still be possible. But as we wind the centuries on, in 400 years' time, this will far outstrip the energy that comes to us through the sun. So for one thing, we really need to think carefully about living in this finite world. But for now, it looks like we should have enough to go around. So how much can we get? So if we go back to our 100 cubes of solar energy per square meter of land, if we build solar PV cells on that land, we can get about 18 cubes of pure electricity. On the other hand, if we wait for that energy to come around in the form of wind or plants, we get about 3 cubes for wind, or we can get about 2 cubes out of plants if we're burning them, or about half a cube if we want electricity from burning them.
So why is that so much less than the energy from the solar panels, James?
So if you think about it, it's sort of like second-hand solar energy. The sun is heating up the air, which is then causing the clouds to rotate and causing air masses to move against each other, which is causing the wind. Likewise, we can have third-hand solar energy, which comes from the waves and hydrological dams, which is damming rivers, basically. So the energy gets even smaller. So you could perhaps have 1 cube out of your 100 for waves and maybe a quarter of a cube from hydro, although this will differ where you are in the world. We can also get 3 cubes from tidal, or probably 1/10 of a cube from geothermal average across the world.
So that sounds easy. Why don't we just cover the whole planet in solar panels?
That's a good question. And solar is an exciting part of the net zero energy future, but it's not all of it. And that's because we have to ask, when can we get it? So these 2 graphs show the solar energy and the wind speed. So the wind energy is in different parts of the UK, which is known as a windy and not particularly sunny place, right? If we zoom in on 5 days towards the beginning of March, we can see that there's large times when it's not sunny. So these are at night, or perhaps it's a kind of overcast day. It's generally quite windy, but the wind could drop off with very little notice. And the idea is that the more diverse mix of renewables we have, the easier it is to match supply to demand, because we're less likely to have a situation where we have nothing to rely upon. So can we supply our future with renewable energy? Purely from a maths perspective and energy perspective, the answer is yes. We can keep fossil fuels locked away underground where they absolutely have to be.
So overall, there are 2 ways of reducing the carbon emissions associated with our energy use. One is to increase the proportion of energy that we generate through renewable means, and the other is to reduce the amount of energy that we use. Unfortunately, there is a balance to be struck here, because energy is also an enabler for human development. Whilst thinking about nationally determined contributions under the Paris Agreement framework, this balance must always be considered to try and ensure that we can come up with the best future for humanity, both in terms of human development and the challenges of climate change.